Hello everyone, my name is Subiksha Bhattrai and today I'm going to talk about quantum computing. But first, let's learn about classical one and its limitation. Computers that we use today, like phones, laptops, or even supercomputer, all rely on microprocessor, which acts as a brain of the system. This microprocessor is made up of millions and even billions of tiny switches called transistors. These transistors control bits, the basic unit of information. But here's the thing, over the years, these transistors have been getting smaller and smaller, following something called Moore's Law, which predicted that the number of transistors on a chip will double every 2 years. But now we are approaching a limit. Recently, companies have managed to make transistors as small as 3 nanometer. To give you an idea on how small that is, a single strand of DNA is just about 2.5 nanometer wide. So we are literally building technology that's nearly atomic in scale. However, at this tiny scale, transistors are almost as small as atoms, and quantum effects like tunneling start to disrupt how they control electricity, making it much harder for classical computer to work reliably. Classical computers are amazing, but they have limits, especially when it comes to simulating complex things in nature, like atoms or molecules. Back in 1981, physicist Richard Feynman, in his seminal talk, suggested that if nature behaves according to quantum rules, then maybe our computers should too. But what exactly is quantum computing? Well, it's a new type of computation that uses qubits instead of bit. A qubit can be 0, 1, or both at the same time. Similarly, quantum computer harness the phenomena of quantum mechanics. Now, let's quickly explore the four amazing quantum effects that make quantum computing so powerful. The first one is superposition. Imagine flipping a coin while it's in air. Is it heads or a tail? It's kind of both, right? That's similar to qubit in superposition. That is, it can hold multiple states at the same time. Another fun example is Schrodinger cat, which is a thought experiment where a cat is in a box is both alive and dead until you open the box. Weird, right? But that's how quantum world work. Because of superposition, quantum computers can explore many possibilities at once instead of checking one option at a time like a regular computers, allowing parallel computation on a massive scale. Next up is interference. Interference is like the ripples when you throw two stones in a pond. The wave interact and can either cancel out or strengthen each other. Quantum computers use this phenomena to cancel out wrong answers and strengthen the right one, hereby increasing the chances of getting a correct result. Another amazing phenomena is entanglement. To understand entanglement, imagine you have a pair of magic globes, one left and one right. You put each globe in a separate identical box and send them far apart. Now, if you open one of the box and see the left globe, then you will immediately know the other box must have the right globe, no matter how far they are. That's like entanglement. That is, knowing the state of one qubit instantly tells you the state of the other. Einstein even called it spooky action at a distance. This phenomena allows qubits to share information and perform complex operations in a highly coordinated way. Last one is measurement. Measurement in quantum computing is not like what you learn in school. In standard science, measurement tells you something that was already there, like the length of a pencil or the temperature of the room. In quantum computing, measuring a qubit actually changes its state. So, before we measure a qubit, it exists in a blend of possibilities, that is, superposition of 0 and 1. But as soon as we measure it, that uncertainty collapses into one definite state, whether one state or 0. It's like finally catching the spinning coin and seeing whether it's a head or a tail. But how does these strange quantum behavior helps us in real life? Well, quantum computers are not for gaming or browsing TikTok. Actually, they are not meant to replace traditional computers. Rather, they are designed to solve problems that are way too hard for regular computers, like finding new medicines faster by simulating how molecule works, or protecting our data, or quickly finding the best solution from many possibilities, or helping in finance, like choosing the best way to invest or speed up AI. And it can also help to predict weather more accurately. Quantum computers are powerful, but they come with big challenges, especially on qubits, because qubits are highly unstable and they can only operate at an extremely low temperature, like near absolute zero, which is lowest possible temperature in the universe. And they are also very susceptible to noise and external environment, and they can quickly lose their quantum behavior due to external factors. Along with this, building a quantum technology is very expensive and also need many expert minds. Quantum computing is still in its early stage, but its potential to transform science and technology is immense. Thank you and stay curious.